endless summer, predictable rain, and not a hint of winter in sight. These are Earth's tropical climates, decoded by the letter A in Köppen's climate map. Welcome to the heart of Earth's tropical belt, where seasons blur, rain falls like clockwork, and winter is just a myth. Today, we're diving deep into tropical humid climates, known in Köppen's classification as Group A, the only truly winterless climates on the planet. So, what are tropical humid climates? Tropical humid climates dominate the tropical zones of Earth, stretching across continents near the equator, only interrupted occasionally by high mountains or dry patches. What makes them special isn't extreme heat, but the absence of cold. Even though these areas are warm year-round, they don't hold the world's highest temperatures. Instead, they offer consistent warmth, where the idea of winter simply doesn't apply. In tropical climates, winter and summer don't mean what they do elsewhere. Here, they refer to the sun's position in the sky, what we call the high sun and low sun seasons. Here, high sun season is the summer and the low sun season is the winter. And moisture? Oh, it's abundant. Thanks to the Intertropical Convergence Zone, or ITCZ, and seasonal monsoon winds, these regions are among the wettest places on Earth. Group A climates are divided into three types, based on how and when the rain falls. AF Tropical Wet, AW Tropical Savanna, and AM Tropical Monsoon. Let's explore each one. Let us first look at the tropical wet climate or AF climate. Found on both sides of the equator, the tropical wet climate of AF climate is typically extending to about 10 degrees north and south, but in locations it goes to as much as 25 degrees poleward of the equator. The largest areas of AF climate occur in the upper Amazon basin of South America, the northern Congo basin of Africa, and the islands of Southeast Asia. The words that define the tropical wet climate is monotonous and consistent. This is because it is a seasonless climate, with endless repetition of the same weather day after day after day. And about the tropical nights, it can be said that night is the winter of the tropics. If we take a few examples of the places lying in the AF climate like from Iquitos in Peru or Singapore, we can see that there is not much difference in the summer and winter temperatures, just 1 to 2 degrees Celsius over the whole year. Here the weather of each day remains same. Morning are bright and clear. In the later part of the cumulus and later cumulonimbus thunderheads, producing a furious convectional rainstorm. The clouds usually disperse by late afternoon leading to a glorious sunset. The clouds may at night and disperses once again to a bright and clear dawn, and the sequence continues. So, each month receives moderate precipitation, that is about 150 and 250 centimeters annually, although some locations may receive more. So, why these climatic conditions occur in the AF tropical wet climates? Here, the main reason is latitude. On the equator, sun remains high throughout the year with minor or no variation. This extensive warming produces thermal convection that causes rainfall. The ITCZ causes uplift of warm, humid, unstable air, and the trade winds are a consistent source of moisture in the east-facing coastal regions. The interiors, on the other hand, are generally calm as they fall under equatorial doldrums due to the lack of horizontal air movement. Next up, the tropical savanna or AW, that generally lies both to the north and south of AF climates, which may extend in a few places to 25 degrees north and south. The regions experiencing AW climate mostly in South America, Africa, Southern Asia, and to some locations in Northern Australia, Central America, and the Caribbean islands. Here in tropical savanna, there are quite distinct wet and dry seasons, a summer soaked with rain and a winter that's bone dry. Rainfall averages between 90 and 180 centimeters, that is mostly in the high sun season. Here, the difference in the summer and winter temperature is much wider than AF climate, which is about 3 to 8 degrees Celsius annually. The AW climates can be explained by their location. These regions lie between the unstable, converging ITCZ on their equatorial side and stable, subsiding subtropical high on their poleward side. During the low sun season, pressure belts shift towards the equator, and now the AW regions fall under the control of subtropical highs, dominated by the dry and clear skies. In summer, the poleward shift of the pressure systems brings the region ITCZ into the AW region, causing thunderstorms and convective rains. And finally, the dramatic AM or the tropical monsoon climate, where seasons are defined by the wind. The AM climates are mostly found on the windward and west-facing coasts of Southeastern Asia, that is primarily India, Bangladesh, Myanmar, and Thailand, but it also found in some pockets in coastal regions of Western Africa, northeastern South America, the Philippines, and northeastern Australia. The distinctive feature of the AM climate is its rainfall pattern. During the high sun season, an enormous amount of rain falls, in association with the summer monsoon, which can be more than 75 centimeters in each monsoonal month. The annual total for a typical AM station is between 250 to 500 centimeters or 100 to 200 inches. The example of wettest place in the world, Cherrapunji in eastern India, is an extreme case of AM region, with an annual average of about 1,065 centimeters. The temperatures in AM climate have a slightly different curve than tropical wet climates because of the monsoonal rains. The temperatures often peak in late spring, just before the monsoons. Once they do, the intense rain and heavy cloud cover cools things slightly, by shielding the incoming solar radiation, resulting in slightly lower temperatures in summer months than in spring. The extremely wet high sun season of the AM climate can be explained by the onset of the monsoonal winds. During the low sun season, AM climates experience offshore winds or the winter monsoon that produces little to no precipitation. In a nutshell, the tropical humid climates are shaped by the sun, wind, and water, on a loop, with very few surprises. So next time you picture the tropics, remember, it's not just palm trees and beaches. It's a powerful dance of atmosphere, energy, and topography. Like, subscribe, and tap the bell for more explorations into the science of our amazing planet. Thanks for watching. Stay curious, and we'll see you in the next one.